Now, let's do a quick recap, because there is, okay, doing sines and cosines, that was easy because they are basically the same, right? So let's do a quick recap of that. If we have an equation like this, let's talk about amplitude, period, phase shift, and vertical shift for this curve. Now you should be able to fill these in, even if you can't graph it, even if you're still struggling with that, you should be able to fill all these in at this point. What's our amplitude?
3.
3. Now what does that mean? That means when I graph this thing, I'm going to go up 3 and down 3, right? At least initially. Okay. What's the period? 2 pi divided by 4, or pi over 2. Remember, this number does what? Divides
2 pi.
the period, which is 2 pi. So that number is going to divide 2 pi. Now what does that mean? If we say the period is pi over 2, what does that mean? Start and finish, the distance between start and finish is pi over 2. So this is shrunk, right, from the normal. All right, phase shift. What's my phase shift here?
Minus pi over 8.
Not
Right.
minus pi over 8.
Right.
Pi over 8. Remember, anything attached to x, it kind of does the opposite of what you think. So this actually goes right, pi over 8. So my curve is going to start at pi over 8. Remember that a normal sine curve would start here, right? This one is going to start here. And what about vertical shift? It's going up 1, which I'll take care of that after a bit. I want to do this other stuff first, but we can take care of that in a minute. Okay, so now let's quickly label these things. Remember, beginning to end, for this curve, beginning to end is this far, right? So if we start at an 1/8 and we travel a half, where will we stop? Where?
1/4.
Oh, you guys, come on.
Pi over.
What'd you say?
Like a fifth. Like
No.
5/8.
5/8. There we go. Good job, Harry. 5/8. Now come on, you guys. If Harry can do this with his eyes closed, you guys need to be able to do this. If you start at an 1/8 and you add a half, where do you end up? 5/8. Absolutely, 5/8. This is not hard. Turn your brains on. Here we go. Now we need the midpoint. What's halfway between 1/8 and 5/8? 3/8. What's halfway between 1/8 and 3/8? 2/8. And remember, I'm not going to be picky about reducing. Sometimes it's just easier not to reduce these guys. What's halfway between 3/8 and 5/8? 3 and 5, or 4. Now, we're almost done. All we need to do now is take this picture and do what with it? Move it up 1. So every point's coming up 1 unit. And the purple is actually the answer to the question. All right? Okay, I want every person in here who is doing review work, except for Tim Kelly, you need to be done. Right now. You need to be done. Michael, it's you too. You need to be done. Now, is something different. Today we are going to graph the tangent and the cotangent. I don't know if it's good news or bad news, it's completely different, completely different. The curves are totally different. And here's why. I don't care if you write this down or not, just kind of listen. If I draw my unit circle up here, my circle with a radius of 1, and I look at the tangent values, what's the definition of tangent? Opposite over adjacent, or what's another definition? Y over x. I'm going to use that one. Then I'm going to look at these ordered pairs, and I have x's and y's as I go around the circle. And I want you to notice what happens when you put y over x. What happens here when you put y over x? Y over x. Y over x. 0. Y over x. Undefined. You can't sit on the egg, remember that. The 0 can't be in the denominator. So up at 90 degrees or pi over 2 radians, I'm undefined, so I have an asymptote. Have we had asymptotes in your sine and cosine curves? No. For the first time now, we are going to get asymptotes in our pictures. Are there going to be any more asymptotes? Go around the circle. Are there going to be any other angles where we end up with asymptotes? I'll just go around the circle one time. So this is pi over 2. Here's pi. Is that going to have an asymptote?
No.
No. How about 3 pi over 2?
It's sitting on the egg.
It's sitting on the egg, so it's going to have an asymptote there. Let's go this way. Let's go negative pi over 2. What about that? Is that going to have an asymptote? It is. Look at this. Asymptote after asymptote.
Oh my goodness.
What happens at these other points? What's the value of the tangent at these other points? 0. So if I just do that, so this is what the tangent curve looks like so far. If I plotted some more points, which I don't want to do because I want you to have time to do your quiz, but if I plotted more points, I would get this shape right here. What does that remind you of? Kind of a cubic function, absolutely. Has the same kind of characteristics. And it goes on forever and ever and ever. I've just drawn as much as I have room for. Would you say that's periodic? In other words, does it repeat itself?
Yeah.
Yep. One piece of repeating stuff would be this right here. Would you agree that if I drew this much, that would really be enough? Because everything else is repeat? Would you agree with that? So when we draw a tangent curve, you know how like a minute ago we drew a sine and I said this is what we start with? Well, when we draw a tangent curve, this is what we're going to start with, okay? That's all you have to draw. What about period and amplitude for tangent? Anybody want to hazard a guess for either one of those? Remember, we're just doing the purple one now. I'll erase the rest so it doesn't get confusing. What? Somebody said it. What?
Pi.
The period is pi. Very good, whoever said that. The period is pi. Now that's different, isn't it? What's the period of the sine and cosine? 2 pi. So, oh boy, we have more to remember. The period of the tangent is just pi. Logan, what's the period of the tangent?
Pi.
Thank you. She's allowed to have her head down because she has a concussion. You are not allowed to have your head down.
Right.
Okay. Now, how about amplitude? There is none. Because, what did I say the definition of amplitude was? Half the distance from the top to the bottom? Where's the top of the tangent curve? Doesn't have one, yeah. So there's no amplitude. All right, so let's see how this manifests itself. Let's suppose I ask you to sketch this picture. Now, I hope, I know this is your very first one, kind of an exciting day, but I hope you just draw something like this. That's what the tangent looks like. Now, I've stuck an extra number in there though, so I have to stop and think, what does that number do? It changes the period, right? And what does it do to the period? It divides the period. Just like it did with the sine and cosine. The difference is, what period do I start with? Pi. So now, I start with pi and divide it by 1/2. So the period of this function is actually 2 pi. That means that from this asymptote to this asymptote is 2 pi. That space is 2 pi. Can you figure out what these labels would have to be then? Pi and negative pi. And you're done. That's all there is to it. You just graphed your first tangent. Good work. How about this one? What's that negative going to do? Turn it upside down. Everybody okay with that shape? What's that 3 going to do? That's not a divider. That is a multiplier. And that actually is going to make your curve steeper. It doesn't really impact your graph too much because we're not really plotting points. But it would be the difference between a curve that looked like let's say this is the normal curve. If you times it by 3, it just makes it a straighter line. It makes it steeper. You don't even need to worry about that when you graph it, okay? I'm going to ask you what's the amplitude. And if you put 3 down, I will mark it wrong. Because what about tangents and amplitude? There isn't any. This will change the curvature. That's all it does. What does this number do?
Divides the period.
Divides the period. Now, what was the normal period? So this one is going to be pi over 2. Groupies. That means that the distance between my hands is pi over 2. Okay? So where will these labels be? A 4th pi. Yep, very good. All right, I want to do a quick intro to the cotangent. And then I want to get these quizzes back to you. Okay, so here's the cotangent. What's the definition of the cotangent? X over y. So when I sketch this, I'm going to be looking at these very same points, but I'm going to put x over y. So are there any asymptotes for the cotangent?
Yes.
Yes. Where are they? Remember, you're putting x over y. 0 is an asymptote. So now we got an asymptote right there on the y-axis. Do we have any other asymptotes? You're putting x over y. Over here, that's pi, or 180. Will I have another one back at 2 pi then? If I go all the way around, I'll have one at 2 pi? And we're just going to keep on going just like we did with the tangent curve. You only need 1 period, so I'll just stop right there. And if I sketch it in, it looks like this. Now I should show you that by plotting the points, but I don't want to take the time to do it. So you're just going to trust me. That's what it looks like. Look at that and look at this. They're the same, aren't they? So a negative tangent has the same shape as a cotangent. What's the period of the cotangent? Pi, just like the tangent. What's the amplitude of the cotangent? None. Very good. Let's do one cotangent curve, just so you can go home tonight and tell mom and dad you sketched a cotangent. So they know that money's worth today. Let's do 2 cotangent 1/5 x. Okay, now what's that 2 going to do again? We talked about it briefly a moment ago. What's that 2 going to do? It's going to make it steeper, right? We're not going to get all hung up about that because we're really not plotting points here. But it's going to make it steeper. The amplitude is still none. There is no amplitude. What's my period? What is it? Yeah, it's supposed to be pi, but I divided by 1/5, so it's 5 pi. This is a cotangent, so it has an asymptote on the axis. If its period is 5 pi, then what will be the label on this asymptote? This is the y-axis right here. This is 0. What will be the label here? 5 pi. And where will we cross? Where will that dot be? 5 halves. And we're done. Where are there potential confusions in this? There's 2 things we really have to be on the lookout for. Can you see? What might be confusing? What?
Period.
Well, you've got to remember that the period of the tan and the cotan is pi. The period of the sine and cosine is 2 pi. So yes, that's one thing you have to keep straight. What else? Okay, remember that when you graph a tangent, the standard tangent, it goes through the origin, right? When you graph the standard cotangent, it has an asymptote at the origin. Important. All right, let me, I'm going to have you graph a few. I mean, if you're graphing like 6 or 7 of those tonight, or 8 maybe. Let's look at these quizzes. I want you to work on them at your table. And I want you to get it figured out. Some of you, like I said, did great. This was a 28-point quiz. Gracie got 32. 28. Norman, you didn't do that. Julia? Anna, you didn't do too bad. Good work.
I know. A lack of color. It's pink, too. It's right there.